So since we do have two angles given to us, we know for sure we can do law of sines. Also, because we've got the angle and the side opposite already given to us, we can for sure do a law of sines. So you can solve this a couple different ways. You can go ahead and like draw a quick picture. Sometimes what I do, you don't have to though. So I put the angles in. If 100 degrees is right here, side C would be across. Side B would be across from 30 degrees, so 2. So this would be side A and alpha. So when it says solve the triangle, we are looking for every other remaining piece of information that's not given to us. So we need alpha, we need A, and we need C. And I'm going to go ahead and put these right here when we're done. So first thing I always like to do is find the angle. Law of sines, I usually just find all the remaining angles first. And it will work every time, no matter what kind of triangle, whether it's side-side angles, angle-side angle, or angle-angle side. So let's go ahead. If there's two angles already given, we know all three angles add up to 180 degrees. So this would be a 50-degree angle. So 50 degrees. And then we're going to go ahead and find one of the sides, and you get to choose which side. So I'm going to start with side A. So in order to find that side A, I've got to use this right here. So I've got sine of alpha, so 50 degrees, over side A. Now you don't use all three of these. The next one I use is the one that has both the angle and its corresponding side. So we already said that was B, because these ones right here are corresponding. So I'll do sine of 30 over 2, because they're always across from each other. And then you cross multiply. So if you cross multiply, you get A sine of 30 degrees equals 2 sine of 50 degrees. I'm going to zoom in just a little bit. There we go. And then to solve for A, you just divide by sine of 30. And then you just type it into a calculator. And let me do that really quick. So 2 times sine of 50. And we divide that by sine of 30. So I get approximately 3.06. So I'll put that right here. It didn't say how many decimal places to do, so I'm going to go ahead. Well, bless me, sorry. And do to the hundredths place. Okay, and then we'll go ahead and find C, and we're going to find C. So this was all side A right here. And notice the only difference we're going to do for side C, I'm going to do side C now, is we're going to do sine of angle, or gamma, and by the way, this is gamma typed right here. So sine of 100 degrees over C equals, and then I'm going to go ahead and use beta and side B, like I did right here. And since those are exactly the same, our answer should be exactly the same, except you switch out the 50 degrees. So 2 sine of 100 degrees instead over sine of 30 degrees. Type that in. So in your calculator, the easy way, if you have a calculator that just lets you retype a portion in, you can just replace that out. The 50 degrees to be 100. So you get 3.94, and you are good to go. You have all three pieces. So the next problem, you'll notice once again we have two angles, so we can use law of sines, but this time we have side B, but we don't have beta. So this is going to be an angle side problem. So like this is 50 degrees, so this is A. Let's say this is 85 degrees, so this is C, because remember this is gamma, which is across from C. And then beta would be across from side B, which would be right here. Sorry, I said angle. Did I say angle side? Hopefully you interpreted it correctly, because I should have just said angle, side angle. Sorry about that. So that tells us when we have angle, side, angle, we don't have the angle across yet. So we can't find the sides until we have that angle. So very first thing is you've got to find that angle, which is why I usually just go ahead and find angles first. That is so small. Beta, A, C. So we're going to go ahead and find beta first. So beta is going to equal 180 degrees minus 85 minus 50, and that should be 45 degrees. And then we found beta. Maybe I'm going to put it in the picture. It's 45. Wow, 45. So now we've got that side across, so we can start finding sides. So I could start with like side A, just because I like alphabetical order. And once again, I'm going to go ahead and set this up. So I've got sine of 50 degrees over its corresponding side, which is A. So equals sine of 45 degrees over 3. Now, I don't know if you ever noticed the quick trick last time, but rather than go through all the steps of cross multiplication, you can always just remember to divide by what's across from the variable. So if I solve this, that means I'll have 3 sine of 50 degrees over, or divided by sine of 45 degrees. And you're going to want some quick tricks because you're going to be cross multiplying like crazy today. Also, I didn't say it on the last problem, and I should have. Please, please, please make sure your calculator is in degrees. If you are not in degrees, you're going to get all the answers wrong. And it's going to be really sad. I had a student one year do every single problem on their homework in radians, and so they had the entire assignment wrong, and it was really sad because they had to redo the whole thing. Don't do that to yourself. Okay, side C. Remember, if you remember our trick last time with this, C should be the same thing except that, oh my, probably should use highlighter. The alpha should be switched out to be gamma. So gamma would be 85 degrees, but everything else should be exactly the same, which is nice because we like where we can take shortcuts rather than having to do all this process over and over and over again, because it's pretty repetitive. So you type it in, you get 4.23, and these are your answers over here, which I hate my box. I'm going to rebox it. You know, important details. So before I end this one, I will do a few more on the next example, or a few more examples in the next video. But I do want to talk about the side-side angle scenario. So we can also, like I said, solve triangles when it's side-side angle using the law of sines. Now, the reason last year in Math 2 we always told you that it doesn't give you congruence, it doesn't prove congruency, is because it creates, anytime you have side-side angle, it creates something called the ambiguous case. And the ambiguous case happens when, or just means that side-side angle can either have 0, 1, or 2 solutions every time. So there are some quick tricks to know, especially between the 1 and 2 solutions. So here's like the big idea. No solutions happens when you've got your angle over here and you've got your given side. This bottom side, let's say, isn't given to you though, so it could be any length, right? We're not sure where it's going to connect. But you have your other side given to you is really, really short. So like right here. And no matter how I swing that side, it is never going to connect anywhere down here and still form this angle. Okay, so that's a situation where you have no triangles. Okay, a one triangle situation is pretty easy to know. There's always one triangle, well, at least compared to the two triangles. It's one triangle if you have an obtuse angle. So I don't know if you guys remember obtuse or right angle. Hypotenuse leg, so if you had this and that side given, hypotenuse leg does prove congruency. Anytime you have a 90-degree angle or an obtuse angle right here, it's automatically going to prove congruency. I'm going to explain why. You have one triangle, even if it's acute, even if it's an acute angle right here, you'll still have one triangle as long as this angle right here, not that angle, sorry, I said that angle, as long as this side right here is longer than the side attached to the angle. So the side across from the angle, if it's the longer side, then you're only going to have one. Two triangles, I'll explain why two triangles, that's not the case. So in the two triangle situation, let's make sure I can kind of draw an example. Let's say I have something like this. You have this side right here, you got at this angle. So this is a much longer, so the longer side's attached. So if I have the shorter side across, like right here, I could actually swing that side out over here and it'd be the same length. That was kind of a horrible drawing. I could swing it out the same length-ish right here and form two separate triangles. So triangle number 1 being right here and triangle number 2 being the blue triangle. Okay? So you could have either the small triangle, oops. In fact, let me separate those so you can see them. But you get the point. Okay? So once again, there are easy ways to verify that. So if you look at this right here, here's one of the triangles, while the other one would look like this. You just take that middle out. Okay, so those would be the two triangles. Okay, so the next video I'm going to go through those, but as just a little taste for that, like I said, if the longer angle, or longer side, I keep saying angle, if the longer side is across from the given angle, then you have one triangle. If this is shorter side across from the angle, then you're going to have two triangles. Okay? So get excited.